Alright, and welcome to the quadratic formula, level 3. Now here, if you'll notice, if we just kind of look ahead just a little bit at problem 1b, you'll notice that the a term is a 6, it's not equal to 1, and you can't divide all three terms by 6. I would argue that this is truly the first time that the quadratic formula actually becomes easier than factoring. But I'm going to show you how to solve 1a with the quadratic formula, and how to use factoring by grouping for 1b, and then you can make your decision on which one of these you actually prefer, because both will get you the same answer. And so this one really just becomes kind of a personal preference. Okay, so let's go ahead and take a look at it. The first thing we want to do when given a quadratic function is label our a term, our b term, and our c term. And in this case, we know that our b term is a -1. We know that the second thing we want to do is rewrite our formula with nothing but parentheses. Okay, -4 parentheses parentheses all over 2 times parentheses. And here, let's go ahead and plug in our terms. Our b term is a -1 and a -1. Our a term is a +6, +6, and our c term is in fact a -2. Okay, so working our way down through this, we have x equals, on the outside, a negative times a negative is a +1, plus or minus, we have the square root of. On the inside of our square root, let's take it step by step, -1 squared really means -1 times -1, a negative times a negative is a positive. Here I have -4 times 6 times -2. If you count your negatives, a negative times a negative is a positive, so our final answer will be positive. 4 times 6 is 24, and 24 times 2 is 48. If you struggle with multiplication, I would truly encourage you to use your calculator. 4 times 6 times 2. And on the bottom we have 2 times 6, which is 12. Now, if you will recall to what we've done earlier, we always want to simplify the inside of our square root one more time. So let's just bring this up here. And now we have x equals 1 plus or minus the square root of 1 plus 48. Well, that's going to be 49. And that's going to be all over 12. Now, if you're good with square roots, you probably know this one pretty easily. The square root of 49 is actually equal to 7. But remember, if you're stuck, you can use your calculator, just type in the square root of 49, and you'll see, oh yeah, that's 7. And this gives us our final setup before we split our solutions. 1 plus or minus 7 over 12. And when I split it up, I have x equals 1 plus 7 over 12, comma 1 minus 7 over 12. And as I walk through that, let's bring it over here to the left. I have x equals 1 plus 7, well, that's positive 8 over 12, comma 1 minus 7, that's -6 over 12. And all I have to do here is just reduce these. I see that 8 and 12, let's see here, let's write it like this. 8 and 12 can both be divided by 4. And so my first solution, 8 divided by 4 is 2 over, 12 divided by 4 is 3, comma, and here 6 and 12 can both be divided by 6. Remember, you always divide by the largest number possible. And -6 divided by 6 is -1 over 12 divided by 6 is 2. And these, of course, are my two zeros. Notice that they're not whole numbers, so these could have been a little bit tricky. Okay, let's see what this looks like on the graph, and then let's find out if factoring by grouping will give us the same solutions. I would encourage you to pause the video, finish taking your notes, and let's get caught up. Okay, so we noticed that our first solution was 2 over 3. So if I come out here at 1 unit, we know that 2 over 3 is less than 1. Think about it in terms of dollars. If you have 2/3 of a dollar, well, that's not a full dollar. That's a little bit less than 1. And we know that -1/2 is less than -1 as well. If you had half of a dollar, well, that's, think of half a dollar as smaller than a dollar, even though negatives, positives, don't worry about that too much. Now, from right here, we then ask ourselves, well, hey, our a term, is it positive or negative? And since our a term is a +6, we know that this graph is going to open up. It looks like the vertex would be just a little bit to the right of that y-axis. Okay, now let's go ahead and find out if these two solutions match when we use our factoring by grouping. Now remember, factoring by grouping is a skill that we worked on in a previous video series. If you're a little bit stumped by it, I would encourage you to go watch the Ultimate Guide to Factoring by Grouping, UG Factoring by Grouping, on the William Hastings channel. Okay, and I have 3 videos there that could help you out with this. Now in this case, because we're actually solving the function, remember for all quadratics we set f of x equal to 0. And from here we say, okay, well 0 equals 6x squared minus x minus 2. And the first thing we always do is we take our a term and our c term and we multiply them. So a times c is 6 times negative 2, which is negative 12. Now if you remember, we're always looking for 2 numbers that multiply to be negative 12, but add up to be our b term, that negative 1. So you think like, okay, well, are there 2 numbers that multiply to be 12? They're a distance of 1 apart from each other? And there are. There's a 3 and a 4. So I know 3 times 4 is 12, but one of them has to be negative. And if my middle term is negative, the larger number has to be negative. Okay, because 3 plus negative 4 is equal to negative 1. So these are the 2 numbers we're looking for. Okay, so this is how we break it down. We say, well, you know what? 0 is equal to 6x squared, so the first term stays the same. And at the way very end, we keep the minus 2. And what we're in fact saying is that this negative 1 could be split up into a, let's say a positive 3x and a minus 4x minus 2. Now if you recall, we call this factoring by grouping because you can actually group these into 2 terms each. And what we do is we actually wind up looking for the greatest common factor. So when I look at 6x squared and 3x, I see, well, the largest number I can divide both 6 and 3 by is 3, and x squared and x can both give up at least 1x. So I say, okay, well 0 equals 3x parentheses, and then I simply reduce. 6 divided by 3 is 2, and x squared divided by x is x. And remember, anything divided by itself is just equal to 1. So 3x divided by 3x is 1. Now from here, I want to divide both of these by a negative because I noticed that my leading term is negative. And 4 and 2 can both be divided by 2. So I pull out this negative 2. And from here, negative 4 divided by negative 2 is positive 2x, and negative 2 divided by negative 2 is positive 1. And notice that my factors, they actually match. That tells me that I'm doing this problem correctly. And I say, okay, well, since 2x and 2x are the same, I can factor them both out, and I write 2x plus 1. And then over here, our second factor, when those reduce away, we're left over with a 3x and a minus 2. Now remember, you're not done. You have to set both of these factors equal to what? Well, you have to set them both equal to 0. So we say, well, you know, 2x plus 1 is equal to 0, comma, and 3x minus 2 is equal to 0. I would encourage you to pause the video, finish taking your notes. Let me pause and clean this up a little bit. Okay, so we have that 2x plus 1 is equal to 0, and that 3x minus 2 is equal to 0. I know that to get x by itself, I can just subtract 1 from both sides, and 2x is equal to negative 1. I divide both sides by 2, and we get x equals negative 1 over 2. Hey, is that familiar? Why, yes, it's one of our solutions that we found from the quadratic formula. Over here, I can do plus 2 and plus 2, and that cancels out. And now I have 3x is equal to 0 plus 2, which is 2. And I divide both sides by 3. Remember, that's just basic algebra 1. And that 2/3, well, that equally looks familiar. And we notice that solving with factoring by grouping and using the quadratic formula, they give you the same results. But I want you to notice that in all 3 levels of video, we've factored 3 different ways, but we've done the quadratic formula the exact same way every single time. So that's the benefit to the quadratic formula. The more you practice a skill, the faster you get at it. So if you choose to use the quadratic formula to learn how to solve for solutions, I think that's an excellent way, especially because the quadratic formula can solve for solutions when factoring can't. Alright, y'all, I hope that this video was helpful, and I will catch y'all in our next video series.